Hey, good evening. Playing around with these voltage sensors for the Arduino. The analog pins on the Arduino will only measure 5 volts. So this is a divide by 5 voltage sensor, which lets you get to 25 volts. So they warn you that as you approach 25 volts, it gets less stable. So what I did is hook up a circuit to test it. I wanted to output on an LCD so I didn't have to keep checking the computer screen. So all I do is read this, display the voltage. I have the sketch that I wrote for this. I'll put it in the website article, and I'll put a link to it in the YouTube video description. It's a very simple circuit. I connected the signal to A0, the negative to ground. The positive is not connected. It's not used for anything. Not sure why they put that on there, but they do. And I have the serial interface on a 2004 20 characters by 4 lines. Pretty simple. I got an adjustable voltage power supply. It'll do 1.5 to 12 volts. In reality, it'll do about 1.5 to 11 volts. So as a backup, I hooked up my multimeter to the same place I'm supplying voltage to the sensor. I want to compare the two and see how they're doing. So we'll look at the LCD here, the multimeter here. I don't have this turned on, but I have it set to 1.5 volts. I'll turn it on. One thing I did different on this is the voltmeter does a constant update. There's like no pause between readings. This one I set to 1 second updates. I don't want to see that wild up and down, up and down. It's bad enough 1 second gives me this much. As you can see, the less than 1 volt reading is like all over the place. That is probably a symptom of the supply since both are doing it. But what happens when I increase the voltage? So I go from 1.5 to 3. Well, that didn't change very much, did it? I don't think this supply is that great. That should be 4.5. As you can see, they're about the same. They're in the same ballpark. They're taking readings at a different interval. So there is supposedly 6. I don't think this thing increments very well. It's a little behind, so that should be 7.5 and it's reading 7. And that should be 12. And when I first hooked this up, I kept getting these wild readings that didn't match. That's why I hooked up the voltmeter. And they're about the same, so that supply isn't consistent in what it puts out. Right now it's putting out 10.5 volts. But these are close. I wanted to measure the voltage from an RF circuit. Now the RF circuit is AC. I convert it to DC, and then I wanted to read it with these sensors. Well, with these jumping around like that, I'm not so sure that's going to work that great. If it's not stable on the decimals, actually it seems to be the longer it's at a voltage, the better it is. But what I'm going to be reading is going to be varying a lot, so I'm not sure how that's going to work. And most of them are going to be low power. I put that to 1.5 volts. This is a crappy supply because it's slowly going down to 1.5. I find that very odd. So let's try a 12 volt supply that might be a little more stable. So to make this easier on me for my experiments, I actually wired a 2.1 millimeter jack into the power so I don't have to keep unscrewing and screwing on different voltage sources. And that's going to pay off right now when I pull off that supply. Plug this one in. Okay, so that's 1604, and it's staying pretty steady on the. Staying pretty steady there because I'm only reading it once per second. This is a continual, and you can see it's jumping around quite a bit. So I think the reading slower might be better. I have to do this with a circuit where I'm measuring RF output by converting it to DC and see how accurate that is. That seems to have stabilized, but this is 1604 and this is 16.2. I'm not sure that that's relevant, to be honest with you. The error between the two seems to be in the neighborhood of 0.2 volts maximum. I did a review of this multimeter, and I'll put a link to that. This thing has a very odd power saving feature. Instead of after so long of no activity, it's so long since you turned it on. So you can see I was using this and it turned off. So they're about 0.2 volts difference. Probably okay with that, because when I measure the RF voltage, I'm going to measure two voltages and give a ratio between the two. If both of them are off by 0.2, then the ratio is going to be correct. I should move forward with the experiment of converting the RF voltage to DC and then measuring it and giving a ratio of two voltages. So I think this is going to work out okay. The 1 second seems to make it more smooth. It's kind of like an average, which I'm pretty okay with. So for a little sensor like this, it actually works pretty good. I would trust this the same as I would trust this. So there's a quick experiment to see how this works. Measuring it against a multimeter reading. You can see they're off about 0.2 all the time. So now I can move forward to the next phase, but that's a demonstration of how the sensor works. So if you like the videos, please subscribe to my channel. Thanks for watching.